I'm Anil Kumar. Welcome to my series on vectors. We are solving a test paper on intersection of lines and planes. In part 1, we saw solution of multiple choice and true and false questions, question number 1 and 2. Now let's begin with the knowledge-based thinking and application questions. Here is question number 3. What is the direction vector of the line of intersection between the two planes? Now the direction vector for the line should be perpendicular to the normals of these two planes, right? So basically we know the normal of the first plane is 3 minus 1 2, and the normal for the second plane is x plus 3y equals to 45, means 1 3 and 0. The cross product of the two normals, n1 cross n2, should be the direction vector of the line of intersection of these two planes, right? You can see that n1 is not a scalar multiple of n2, right? That means the planes will intersect in a line, right? So direction of this line will be perpendicular to the normals, correct? Okay, so to find the cross product, let's do 3 minus 1 2 cross 1 3 0. Now there are different ways of doing it. So one of the method is you can write them like this, starting with the center number minus 1 2 3 minus 1, and this 3 0 1 3, and then these terms which are diagonally coming from like this left to right, they are positive numbers. So we can write this cross product as this positive minus these, correct? Minus these. So these are negative and those are positive, right? So we get each component. It's a vector quantity. So what we get here is minus 1 times 0 is 0, negative 6. Here we get 2 minus 0, which gives us 2. 3 and 3 is 9. Minus 1, minus minus makes it plus 10, correct? So that becomes the direction vector for the line, right? So we could actually write this by taking a common factor of 2. So we can also write this as minus 3 1 5. Now normally we keep this as positive. So at times in multiple choice question you may have this option as 3 minus 1 minus 5. Does make sense to you? So that becomes the direction vector of our line, right? So our answer here is that the direction vector D of line of intersection is, I'll write this as 3 minus 1 minus 5. Clear? Here is question number 4. Determine the intersection if one exists and classify the system as consistent, inconsistent, independent, dependent. So we are given an equation for 3 planes. If the solution exists, it will be consistent, right? Now independent and dependent means if we have same planes or scalar multiples of normals, then they are dependent, otherwise they are independent, right? We'll use augmented matrix to solve this system. So let me rewrite the augmented determinant in this case. 6 1 minus 2, we get 6 1 minus 2 equals to 4. Here we get 1 3 0 3, and here we have 0 minus 1 minus 4 minus 1. Now we already have a 0 here, so first step, let's make that as 0. So to make this as 0, what we can do, we can multiply R2 by 6 and then take away R1, right? So this is what we could do. So we'll just copy R1 as such, which is 6 1 minus 2 4. And here 6 times 1 is 6, taking away we get 0. 6 times 3 is 18, taking away 1 gives us 17. 6 times 0, so that taking away will give us plus 2. 6 times 3 is 18, taking away 4 is 14. And here we have 0 minus 1 minus 4 minus 1, correct? Now to get this as 0, we can multiply R3 by 17 and add it to R2, right? So we'll keep the first row as such, which is 6, 1, minus 2, and 4, right? The second one, also same. We already have 1 0 there. Okay. Now we need 0 at this place. So we'll multiply R3 by 17, and then we can add it to R2. Correct. So when we add, we get 0 here. 17 and 17 will make it 0. Negative 4 times 17, let's do it. So we have 4 times 17. And then from there, we have to take away 2 minus 2, which gives us 66, right? So, and it's negative, right? So, we have to add it basically. So we get 66 here with a negative sign. So negative 68 added to 2 gives us negative 68, right? Now here we have negative 17. When you add it to 14, you get minus 3. Well, that gives us a point of intersection, right? So that implies that we have a point of intersection. So let's calculate this point. So we have minus 66z equals to minus 3. So z is equals to 3 over 66, which is 1 over 22. So that is one value. And now we can actually solve for y. So we have 17y plus 2z equals to 14. So 17y equals to 14 minus 2 times 1 over 22, right? So we get, let's find out how much it is. So it is basically 14 take away 1 divided by 11, which is 153 over 11. Now we'll take that from, we'll divide this by 17, right? So y equals to 153 over 17 times 11. So we'll divide this by 17 to get our answer, which is 9 over 11. Clear? So 9 over 11 is the value for y. Now we have both these values. We can now solve for x. We get 6x plus y minus 2z equals to 4. So we have 6x equals to 4 minus y plus 2z, right? So we have this as equals to 4 minus y value is 9 over 11 and z value is 1 over 22. So we write this as plus 2 over 22, right? So which is how much? Let's calculate. So I'm using calculator, which is not a must, but you know, in this it is allowed. So minus 9 divided by 11, and then from here we'll add 2 divided by 22, and we get here equals to 36 over 11. So x is basically equal to 1/6 of 36 over 11, which is 6 over 11, correct? So we get 6 over 11 as the value of x in this particular case. So we have a point P whose coordinates are 6 over 11 for x, 9 over 11 for y, and z is 1 over 22, correct? So that is our solution. So we have a consistent system which is also independent, where the point of intersection is 6 over 11, 9 over 11, 1 over 22. Is that clear to you, right? So that is how we can solve this system of equations. I hope it is absolutely clear. So let's move on and take question number 5. Question number 5. Calculate the intersection, if any exists, between the following lines. L1 and L2, we are given two lines in R3. To find the point of intersection, let us write them in parametric form. So the line L1 can be written as what? So here we have a point P which is 4 minus 2, 0, and the direction of this particular line M1 is basically equal to minus 3 minus 4, 2, right? So we could write this equation as x equals to 4 minus 3t, let's say, and y equals to minus 2 minus 4t, and z will be equal to 0 plus 2t, correct? Where t belongs to real numbers. So we have t belongs to real numbers. Now as far as the second line is concerned, let's write down its equation also, and then we will use substitution or elimination to find the point of intersection. So here the point is 14 to 12, and that is the direction. So we have x equals to 14 plus 5n, y equals to 2 plus 2n, and z equals to 12 plus 6n. So that becomes a set of symmetric equations for the two lines. Now what we notice here is that z, we could equate this point to the same thing and then isolate t. So these two are good equations to work with. So using these two equations, we get 2t equals to 12 plus 6n, or t is equal to 6 plus 3n. Right? So we get our equation t equals to 6 plus 3n. Now we can substitute this value of t to, we can use now the second set of equations, and there we can substitute t and find the value of n, right? So we'll use this set of equation, and now we can write this as these are the two y points which should be same, right? So we have 2 plus 2n equals to minus 2 minus 4 times t, right? So we are equating these two equations. Now t can be substituted as 6 plus 3n. So we have here, we can actually divide by 2 also. So we can write this 1 plus n equals to minus 1 minus 2t, right? Now we'll substitute. So take this one also on the right side. Okay, so we'll do it later. 1 plus n equals to minus 1 minus 2 times t in terms of n is 6 plus 3n. Let's open this bracket. We have 1 plus n equals to minus 1 minus 12 minus 6n. Bringing 6n to the left side, we get n plus 6n equals to, this is minus 13 minus 1. So 7n equals to minus 14. N is equals to minus 14 over 7, which is minus 2. So once we get the value of n as minus 2, we can substitute it back into our first equation and find t also, right? So we'll substitute that in this equation. So we get 2t equals to 12 plus 6 times minus 2, which is the value of n, right? So 2t is equals to 12 minus 12, so that gives t as equal to 0. So we get the value of t as 0. Now we can now find the points, correct? So we can substitute the value of t as 0 in our equation and find the points. So we'll substitute in the first set of equations, which is this one, correct? So what we get here, x equals to 4, y equals to minus 2, and z equals to 0 as our solution, correct? Now, the idea here is, this is what we get. Now, n is minus 2. So we need to check this solution. So for n equals to minus 2, what happens? So if n is equals to minus 2, let me substitute in the second equation. We get x equals to what? So when I substitute minus 2 here, we get 14 plus 5 times minus 2. That is indeed 4. The y value is 2 plus 2 times minus 2. So that is indeed minus 2. And the z value is 12 plus 6 times minus 2, which is also 0. So it confirms that both the points on the line are exactly same, and therefore we do have a solution, correct? We do have a solution, and so we can now write down our solution is that the solution exists, right? And the point P of point of intersection in this case is 4 minus 2, 0. Correct? So that is our answer. So answer is point P is 4 minus 2, 0. Is that clear? Question number 6. Find the intersection of the line x equals to 2 plus t, y equals to minus 2t, z equals to 1 plus t. And the plane pi is minus 5, 0, minus 5 plus p, 1, 4, minus 3, q, 2, 1, 2, where t, p, q are all real numbers. Now to solve this particular equation, to solve this question, we need to write the plane in Cartesian form. So as far as the plane is concerned, we are given two directions, right? So direction 1, here is 1, 4, minus 3. And the second direction given to us is 2, 1, 2. To find normal, we can do the cross product between these two direction vectors, correct? So let's find the normal for the plane pi. So the normal will be cross product of 1, 4, minus 3 and 2, 1, 2. So let's figure this out. So we get, we'll use this technique. We have 4 minus 3, 1, 4, and then we'll write 1, 2, 2, and 1. So these quantities will be positive, right? And the quantities in the reverse direction will be negative, right? So these will be positive. So we get our vector, which is going to be 4 times 2, 8, minus of minus 3 will be 11, right? Minus 3 times 2 is minus 6, minus 2 is minus 8. 1 minus 6 will give us minus 5. So the normal vector for the plane is this, right? Since we don't know the normal vector, we could write the equation of the plane in the Cartesian form as 11x minus 8y plus minus 5z plus d equals to 0. Now to find the coordinates of point D, we'll use the point minus 5, 0, minus 5. So we have 11 times minus 5 minus 8 times 0 minus 5 times minus 5 plus d equals to 0. So that gives us minus 55, that is 0, and this is plus 25 plus d equals to 0. So that gives us the value of d as equal to, when you take away, you get 30 here, right? So d equals to 30. So now we have equation of the plane in Cartesian form, which is, let me rewrite here, the equation of the plane is 11x minus 8y minus 5z plus 30 equals to 0. And we also know the Cartesian, the parametric equation of the line, which is given here. We can find the parameter t by substituting the values of x. So we now get 11 times x is 2 plus t minus 8 times minus 2t minus 5 times 1 plus t plus 30 equals to 0. So let's find the value of t. 22 plus 11t minus minus is plus 16t minus 5 minus 5t plus 30 equals to 0. Okay, So the t terms, 11t plus 16 minus 5, gives us what? Okay, so let's use calculator. Okay, so we have 11 plus 16, and from here we'll take away 5. So as far as t is concerned, we have 22t, and the numbers is 22 plus 30, right? Minus 5. Okay, so we have 22 minus 5 plus 30, which gives us 47. Okay, so that is positive 47 equals to 0, right? So we added 22, took and then 30 is 42, and then we took away 5. Okay, so we get t as minus 47 over 22. Okay, well, divided by 22. That's it. So we get a value of t which is minus 47 over 22. Well, you can check the calculations, right? However, we'll go ahead with this and substitute this value t here to find the value of x, y, and z. So we have x as 2, the t is minus 47 over 22, right? So we get 2, which is 44. So we get minus 3 over 22. Okay, so that is x value. As far as the y value is concerned, it is minus 2 times. So it'll be positive, and we can write this as 47 over 11, and the z value will be 1 plus this, which is minus 47 over 22, right? So let's do this. We have 1 minus 47 divided by 22, which is equal to minus 25 over 22, right? So I'm not very sure whether these calculations are right or wrong. However, this is the actual method, right? So we do get a point of intersection, and the point of intersection between the line and the plane is for us minus 3 over 22. Y value is 47 over 11, and z value is minus 25 over 22. Correct? You may do your calculations and write down the correct answer in the comments below, right? Okay. Now let's take the next question, which is question number 7. For what value of k is the plane minus x, y plus z plus 2 equals to 0, 5 square root 3 units from the other plane, which is minus x, y plus z plus k equals to 0, right? So we need to find distance between the two planes, right? So basically in this case, we need to find distance between two planes, and this distance should be equal to 5 square root 3. That is the whole idea, right? So what we are going to do in this case is we can take a point. So take a point on the first plane, which is minus x plus y plus z plus 2 equals to 0. So what we can do is we can substitute the values of x and y and get the value of z, for example. So that could be z equals to, if I substitute 0 here, right? So let's take 0 here, right? If I substitute 0 plus z plus 2 equals to 0, that gives me z equals to minus 2. So a point on this plane could be 0, 0, minus 2, correct? So we'll use this point on our first plane, correct? Now we can find the distance using the formula. Distance is always absolute value. So we are looking for an absolute value of, in this equation we'll use the point, which is 0 plus 0 plus 0, right? So we have added these values, x plus y, z is minus 2, I'm sorry. So we have minus 2 for z, minus 2 plus k, right? That divided by the magnitude of this, which is a square plus b square plus c square, right? So that is it. And this should be equal to the given value of 5 square root 3. Is it correct? So that is how we are going to solve it. So what we get here is, this is square root 3, right? So we get k minus 2 equals to 5 square root 3. So that is square root 3 multiplied by square root 3, which is 15, or the value of k is 15 plus 2, which is equal to 17, right? So that is one value. Well, for some of you, what we should do is we can find the other value also. It is interesting to note that we have actually the value here is absolute value of minus 2 plus k equals to 15, correct? We are solving for this. So if I assume this to be positive, this becomes one solution, correct? The other solution could be, this could be negative also, right? So option 2 is we could do 2 minus k equals to 15, and in that case the value of k, taking this on that side, will be 2 minus 15 or equals to minus 13, correct? So there are actually two possible values. So let me write down our answer, that k is equal to 17 or minus 13, correct? So both are possible for this value of 5 square root 3 as the distance between these two planes. Here is the last question of our test paper, which is write a reduced row equivalent form of a matrix to represent possibility of three planes intersecting in triangular prism, right? So that's, we need to, that means the planes are inconsistent, and two planes intersect in the form of a triangular prism. So what could be the solution? Well, the solution could be basically what we're looking for is the last row should be is 0 equals to something, right? So that makes it inconsistent. Does make sense to you, right? So the last row should be kind of like this, and that should make it inconsistent. But once we have this, then the other two should give us a solution, right? So we should have, let's say, zero some number here, right? You could put any number, right? Let's say you can put anything here. So let's say a number here, right? A number here, or here also we have some number. Is it clear to you? So that should give you a solution which is for a triangular prism, right? So possibility is there. So that is kind of a reduced row equivalent form where we are expecting the planes to intersect as a triangular prism, correct? So that could be our solution. So I hope that makes sense. So that really means that the two individually, the planes are intersecting in lines, right? So we have, for example, we have a plane here, right? So let's say that it intersects another plane in a line here, correct? So let's say we have a plane going like this in front, right? So let's say we have a plane here. However, the third plane does not intersect at this line. The third plane intersects in a parallel line, right, with both these planes kind of like this, but at a different location. So one could be over here with this plane. The other one could be here with this plane. Do you understand? So that forms a triangular prism which you see here, correct? So that is what well, okay, that is what it is, kind of. So that is the triangular prism which we are looking for. And so we could have an equation something like this to get triangular prism as our solution. So I hope that makes sense. In the next video, I'll take a few examples where we'll have actual values, and we'll see when do we get a triangular prism, when do we get a point, and when do we get a line of intersection, right? So that will take in another video. I hope with this you understand how to solve question paper based on lines and planes. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.